In this lecture, we are going to see the bottom view of a binary tree. If you see this tree, the sample tree which I have drawn here, the bottom view is the view which you will see from the bottom side. So the first view, if you go from the left hand side, 11 will be coming, then 5 will not be coming because only the 4 will be visible from bottom. So the 4 is there, and then comes the 2. So the 2 is there. 7 will not come because it is hidden by 9 because you are looking from the bottom side. So 9 will be there, and then 6. So this is what we call as a bottom view. That is, any tree, if you are looking from the bottom, the things which will be coming can be considered as bottom view. And generally the trend is to print from the left hand side. You can go with the right hand side also. So the thing is that 11, 4, 2, then 9, then 6. This is the bottom view. So how to print this data? The first thing you need to capture in mind is that you need to traverse the tree. For traversing, you need to maintain a kind of map. In map, you need to take the distance from this till left hand side and do a -1 here. Suppose you are moving at 5, then go put 2 as 0, then 5 as -1, then 11 as -2. Again, if you are going in the forward direction, then put 2 as 0, 7 as 1, then 21 as 2. Keep on adding. So right hand side keep on adding, and left hand side keep on subtracting. So you will get a horizontal view. What about the vertical view? Vertical view, you simply need to put 2 as 0 and keep on adding 1 while going to the bottom. So in this way we can maintain both horizontal distance by left hand side by minus and plus with right hand side, and bottom distance by adding 1 at each step or each edge, you can say. So we will create a map to maintain this horizontal and vertical distance. So this map will be simply a map with integer to maintain the horizontal distance, and we need a vertical distance also. For vertical distance, I will create an array in which I will store the data. You can take any form of data structure. I am putting it as an array only. In the first index, I will put the exact data, and in the second index, I will put the vertical distance. So I will put a map equals new hash map, or you can maintain a tree map. The reason for putting a tree map is we can maintain the order and print from the left hand side till the right hand side. Otherwise the order will not be there. Any 4 can come before 11 or somewhat a distorted order will come. So just to maintain the order from left hand side till right hand side, I am maintaining a tree map. And for, I will write, instead of for, let me just call print function, or you can go with short print bottom utility. You can create this function. Inside you need to pass this map, and also you need to pass the head node which is coming here. This is the head node which has been passed, that is the head node is 2 here. And after that I will just call horizontal distance. So I will start from 0, that is from the node itself, and also the vertical distance I will start from 0 itself. I will create this utility function print bottom util, and just after that let me do the formatting. Inside I will just check the edge cases, that is if head comes out to be null, then I need to just return this function. Otherwise I need to check whether the map contains this horizontal distance or not. So I will check if it does not contain, that is map dot contains key, and the key which I have passed is this one. Make it as horizontal distance as HD, and I will maintain the vertical distance with this, that is VD. So if map does not contain any horizontal distance key, which I am putting it as integer here, so I will just simply put map dot put this horizontal key here. So I will put HD and maintain the integer array which I have just need to pass here. So the array in which we will put the data should be head dot data only, and the vertical distance I will also require, so I will put VD. Vertical distance is required. Why it is required? To maintain, that is at what point it is coming. So if 5 is coming at vertical distance of 1 and 4 is coming at vertical distance of 3, then 3 is the bottommost, 5 is not the bottommost. So I need to check at horizontal distance of -1, that is 5 is at -1 because 2 is at 0. I need to check whether the vertical distance of 4 is maximum or not, if it contains at any data at -1. So I need to check that only, that is if the already contained map data, map dot get horizontal distance, and inside that I have stored the vertical distance at the first array, the existing data is less than or equal to the current vertical distance, then the current vertical distance is at bottommost point. Like 5 is at 1 and 4 is at 5, then one distance, that is 4 is at 3. So 3 is more bottommost than 5, so I need to replace it. So I'll just put map dot put with same horizontal distance. I need to replace the existing data. So I'll put new int and replace the head dot data with the vertical distance, which is more bottommost. In this way we can store the data with horizontal and vertical distance also by comparing horizontal and vertical from the root node. After that I'll simply call the print bottom utility function. Head will be passed, but head dot left I will pass. Then map will be same. Horizontal distance, since I am passing in the left hand side, as I said, if I am moving in left hand side direction, I need to do a subtraction, that is -1. Vertical distance I need to add, because every time we are going bottom side, we are incrementing the bottommost side, and simply goes for the right hand side also. I'll do a traversal now. After doing left hand side, I'll do right hand side traversal, and map is the same only. If I'm moving in right hand side direction, I need to add 1 to the horizontal direction, and bottommost, as I said, if I am going in bottom, I need to just add it. So in this way, we'll store all the data in the map, and data which is stored in the map will be on the basis of comparison of horizontal distance and vertical distance, and bottommost nodes are being shared in the map. After sharing all the data in the map, I need to just print it. So I'll write for int, and I am having array, integer array I in the map. So I'll write map dot values, and I'll simply print sys out, and I will write map data here. So the data which will be coming will be I at index 0. See, I am passing head data, that is data at the node 0, the data which is available in the node, I am passing at 0th index. So I'll just simply call I at 0 position, and to look much better, I'll write sys out, and I will say map, or you can say bottom view is bottom view of tree. View of tree is this. So I'll just run it, run as Java application. So it is saying 4, 11, 4, 2, 9 and 6. So if I go to this tree, so 11 is coming at bottommost point at this view, then 4 is coming, 5 is not coming because 4 is at bottommost, then 2, then 9, 7 is not coming, and 6, 21 is not coming because 6 is the bottommost. In this way, we can print the bottommost view of a binary tree. Now the problem arises if the interviewer twists some function and says, instead of printing from this side, that is left side till right side, that is 11, 4, 2, 9, 6, you need to print from 6, 9, 2, 4, 11. That is not from left hand side till right hand side, but instead of this, you need to go with 6, then 9, then 2, then 4, then 11. If you are asked to do, then a normal twist, or you can say small twist, is there. The thing which we can do is to go with this bottom view. Since you are iterating from left hand side and going to the right hand side, and taken this left hand side as -1, and you are passing this in the tree map, the tree map sorts the data on the basis of the horizontal distance, because you are passing in the integer, that is the horizontal distance you are passing, you can see. So the thing is, if you are passing horizontal distance with the left in the negative form, the tree map will sort this data and put all the data in the left in the starting. So if you need to twist this, you need to print from right hand side and go to the left hand side. You need to put the right hand side horizontal distance data as negative and left hand side as a positive, because horizontal distance is the only distance which is being passed in as a key. So instead of putting left in the left hand side, or you can say negative, I will just put it in the positive way and right in the negative way. So now the thing is that the right will be having the key as negative, so the right data will come in the starting and left data will come in the end as it is in the positive way. And since negative will be coming first in the tree map, you can directly put this. So I will run it as Java application. So you can see 6, 9, 2 for 11 is coming, because we have put right as a positive, a negative, and left as a positive. So if you go to the output result, so 6, 9, then 2, then 4, then 11 is coming, because we are going from traversing from right till left. Thank you all for watching the video. Other way around can be there, like you don't need to put plus and minus here, and you are simply using Java in this data structure. You can go with the comparator, light comparator dot reverse order. So the thing is, the tree map internally it will sort this data, and instead of ordering it in from negative till positive, it will sort from positive till negative. So I am keeping this data same as it was earlier, and if I run again this, the same reverse order will be coming, because we have passed comparator dot reverse order in the constructor of tree map. This is how we can print that tree in the bottom view, and along also both in left hand side till right hand side and from right hand side till left hand side direction. This is about bottom view of binary tree. Thank you all for watching the video.